Now, guys, let us try to understand further what all samples we are getting to analyze, and respectively what all important is in that samples. So first thing is the fuel oil sample. When do you take the fuel oil sample? So whenever you are taking bunkers, you send the sample from the bunker manifold. You will collect a representative sample in the cubitainer, and then you will collect in a designated sample bottles provided by the lab that you are sending for analysis. Say it is a visual lab or a VPS lab or any lab for that matter. It will give you phobos lab the specific sample bottles with all the details, like what all details will be there, like your vessel name, uh, etc., bunkering port, which bunker you have taken, what quantity of oil, what grade of oil, and the chief engineer signature, etc., has to be there in the bunkering uh, course that we have recently concluded. We have discussed this sending for analysis, how you will take samples in that in more details. Okay.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mother.
So this is how you will send the sample for analysis, and I've already discussed, if you have to take say you have to send sample for a longer duration of time, you will mix both the samples together, and then say both the cubitainers oil together, make a homogeneous mixture, and then you will take sample, collect the sample for that, and then you will send it to the lab. Now let us see one by one how a sample analysis report for the fuel oil looks like. So if I take you to the fuel oil sample analysis report, this is an exact sample analysis from one of the vessels of how a sample analysis looks like. The lab test, etc., lab name, etc., has been blurred out, so that you can just know about what is important in the analysis report. So this is one of the analysis reports. So first line you can see here directly, the sample is testing with respect to which one, table 2. Let me just take, okay, table 2 of the ISO 8217/2025. So what is table 2 here? What I am talking about in table 2? Table 2 is the grade of residual. So there are two grades when I am talking about the oils in the ISO 8217 is to 2005. Basically ISO 8217 is your marine fuel grade standard as per the ISO specification, marine fuel grade, right? Grade specification ISO 8217. As there will be changes there, so you will be having the name of the year on which the change was brought. So standards as per this year, as per the 2005 standards, these were the levels of the fuel oil in the bunkers that was provided. Or currently ISO, next one is the ISO 2017, and then ISO 2024. This is the latest version. So in the 2005 version you have got two tables. One table is for the DM grade, distillate marine grade, and the other table, table 2, is for the RM grade, residual marine. Residual marine means your heavy oil, VLSFO, ULSFO, etc., coming in the residual oil. Distillate marine, your distillate marine is your diesel oil, LSMGO. Okay, these are coming under the distillate oils. Okay, petrol, gasoline, etc., coming under the distillate oils. So as per this table confirms into, this is the first line of the of your fuel oil analysis report. So as per the conformance of the table 2 of the ISO 2005. Okay, now bunkering information is the first data that you are getting here. The bunker date on which you are bunkering took place, which port the bunkering took place, who was the bunker supplier, okay, name of the company, which barge supplied you the bunker, where did you collect the sample from. This sample that you had sent for the lab for analysis, you collected it from the manifold. What type of sampling method, these ones you have to mention when you are sending the lab your analysis bottle. Okay, in the bottle the sections are there for this, which method was used and from where your sample was selected, from the manifold and from the drip sampling method. Why drip sampling method? Because by drip sampling means drop by drop complete bunkering process has been collected into one container and then you are sending it for analysis. So drip sampling means that it does not mean ki initially if the bunker was say good and some bunker bar did some mm, mixing while the bunkering was in progress and in the end they supplied good bunker. So what happens if you are taking it, say in the end you are getting only good quality of the bunker and say in between they pumped something wrong, say they pumped sludge or seawater or something like that, you will not be able to identify. That is why representative sample for the complete bunkering process is important. It should be representative of the complete bunkering process. Okay, what grade of oil is this? So this is the residual marine grade and they have mentioned RMG 380 0.5% is the sulfur quantity. RMG 380 0.5% sulfur content. Density as per the BDN. So this is the BDN information. So this is the bunker information. Where this information this lab has got? You have sent the lab bottle, right? So in the bottle you have filled this information. This is as per you, they have just printed it on your sheet report for the identification. Okay, sample details, bunker information and BDN information. BDN, because a copy of BDN is always sent with the bunker analysis. Copy of BDN along with this goes, right? And they have got a sheet. The bunker test fuel testing company will always have a apart from the bottle they will also have a sheet where you will fill the information, so and so seal number and etc date and all, and then you will send it along with the BDN. Copy of a BDN goes with the bunker test bottle. Okay, so as per BDN this is the density. So here you will see in the lab report there can be change in the density also. So there is 935.9 as per the BDN. When you see the lab report you can see there will be a difference in the density. This is the first one you can see here, density at 15 degrees centigrade. As per the BDN information you had got 935.9 but actual tested reports you are getting 935.4. so there is a change in density. There is a change in density and sometimes when it varies with a large number, with a large quantity of bunker, this actually results in a bigger difference in the oil, okay, quantity. So basically mass of oil that was coated and the mass of oil you got was different because per meter cube you have got 935.4 kg and earlier it was quoted as 935.9. So density is less, so lesser density you received, so maybe a little bit of oil you have received is less as per this data. Okay, so viscosity at 50 degrees, this is from the BDN, 50 degrees centigrade 355. Sulfur percentage 0.479. This is from the BDN, this is the lab has not done. Quantity of oil was bunkered was 492.371. Sample was taken on so and so date 2026 report date. Okay, and this is how, and then there are seal numbers. Okay, lab seals number was mentioned and sent. You can send also the marpol seal number, ship seal number, bar seal number also on the uh, sheet. Okay, so that also you have to write here. Okay, in general, what comments this one vessel has given, that sulfur high alkalinity of some cylinder oils cause scuffing and excess wear of the cylinder oils. Make sure the cylinder oil used can handle the low sulfur oil. So this is a general comment they have seen over the period of time. This is not relevant or related to this specific oil type. They are saying that, see, because cylinder oils are used, say TBN of the cylinder oil is very high, say 70 TBN is used for low sulfur fuel oil, which does not require this level of neutralization. So they are asking you to use a lesser TBN cylinder oil for neutralization. So this is not just, this is just general comment given by the fuel oil tester. Okay, minimum transfer temperature for this oil they have found to be 43 degrees centigrade. So bunker tank, you will have to keep the bunker tank at this temperature above 40 degrees centigrade. Depending on the density and viscosity, they have found that this is the transfer temperature. So don't, when you are running the transfer pump, make sure that it is above the bunker tank, it is heated up and it's above 43 degrees centigrade. Okay, now this one is important. This is the injection temperature. So injection temperature means the temperature at your main engine inlet. Now here, what is important, that what we want is 13 cst at the main engine inlet. Basically, as per the main engine's maker, you require the viscosity to be 13 cst at main engine inlet. For that, your oil temperature is from the heater outlet, it is 133 degrees centigrade. So one thing is, on the viscotherm, there are three parameters that can be set. So one parameter is your viscosity, say you want 13 cst or whatever cst. One parameter is your density of the oil, okay, and one parameter is your temperature. On the basis of that, the viscotherm is going to work and relay your values. So basically what we do is, at the viscotherm we set around 12 cst. Why? Because, say 137 degrees centigrade, because what happens is, it's a general observation that this oil after the heater, even if you are providing steam tracing lines and all in the line after the heater to the main engine, the line temperature drops by around 4 to 5 degrees centigrade. So as the line temperature drops by 4 to 5 degrees centigrade, if you are keeping it at 133, the oil temperature is going to be 128 when it reaches to the main engine. So by 128 it becomes 15 cst. So in the, it will not you will not be able to realize it in just short span of time. Over the period of time, 4 5 years, when the vessel has been running under such conditions, there will be degradation of the components of the fuel oil system. Say fuel pump, fuel injector, etc., will have some repercussions due to this effect. So what generally what we are doing is, we are keeping the oil temperature at 12 cst, so that this drop in oil temperature by to the engine inlet has to be uh, made up for. Okay, so one important section is this. So from this section, you will decide as to what will be your so for different oils, your injection temperature at say 12 cst or 13 cst will be different depending on the oil type. Okay, so from the fuel analysis report, you will judge how much we have to keep the injection temperature at, or how we will set the viscotherm. Okay, now coming to the lab analysis report. Total quantity was supplied to be 492.371 as per the BDN. See, since there was a difference in the bunker BDN uh, density, so you can see 0.5 is the difference. Bunker BDN does not provide you water quantity, So in the test results, they got the water quantity as 0.15. Total quantity supplied was 492, and due to density, the difference was found to be 0.2, which is very negligible amount. 0.2 metric ton is the amount. 2.2263 is the amount of water, is the shortage due to um, density. Sometimes this becomes very huge, and there is a provision to give letter of protest to the bunker barge, since if you are not aware of how much, so there will be a difference in density. Some of the companies have got a procedure that to avoid any miscalculation or avoid any challenges further, what they will do is, as soon as the bunker barge comes, they will give you a um, their analysis report, and then just you will give them a formal letter of protest saying that we are not sure about the density that is being mentioned in the analysis report, barge analysis report, and we will rely on the analysis report sent by the lab, independent lab. Given on that basis, we will decide on the density. So there can be a difference in the oil quantity supplied by the BDN quantity. Okay, so some of the companies have that process, that they will give letter of protest to the bunker barge on that case. Okay, if the water content increases, here say water content is more, in that case also, because of more content in water, your oil will be shortage. So that is also one case here mentioned, quantity shortage due to water content. Okay, that also your lab will judge. Now this is the table or parameters as per the ISO 8217. Okay, you can see these are the ISO limits. Okay, now one important thing here to note is one important thing here to note is, uh, you have got the values as per the ISO limits, and then you have got the values, some values which are non ISO also. Okay, so about these reports we will be discussing in the next section, guys. Okay, thank you.